One action. Okay. Hi. This is the report of Unit 4, representing by me, Louis Dave G. Mozar, and as well as Joshua Pardillo and Leonard Ibo. Okay, so this topic is all about um, topology. So, what is topology? Uh, network Network topology refers to how various nodes, devices, and connections on your network are physically or logically arranged in relation to each other. Think of your network as a city, and the topology as the roadmap, just as there are many ways to arrange and maintain a city, such as making sure the avenues and boulevards can facilitate passage between the parts of town getting the most traffic. So there are several ways to arrange a network. Each has advantage and disadvantages, and depending on the needs of your company. Certain arrangements can give you a greater degree of connectivity and security. Wait. Okay. So there are two approaches to network topology: physical and logical topology. Physical network topology, as the name suggests, refers to the physical connections and interconnections between nodes and the network, the wires, cables, and so forth. Logical network topology is a little more abstract and strategic, and referring to the conceptual understanding of how and why the network is arranged the way it is, and how data moves through it. So, why is network topology important? The layout of your network is important for several reasons. Above all, it plays an essential role in how well your network functions. Choosing the right topology for your company's operational model can increase performance while making it easier to locate faults, troubleshoot errors, and more effectively allocate resources across the network to ensure optimal network health. A streamlined and properly managed network topology can increase energy and data efficiency, which can in turn help to reduce operational and maintenance costs. The design and structure of a network are usually shown and manipulated in a software created network topology diagram. These diagrams are essential for a few reasons, but especially for how they can provide visual representations of both physical and logical layouts, allowing administrators to see the connections between devices when troubleshooting. Um, the way a network is arranged can make or break network functionality, connectivity, and protection from downtime. The question of what is network topology can be answered with an explanation of the two categories in the network topology. Number one is physical. The physical network topology refers to the actual connections, example, wires, cables, etc., of how the network is arranged. Setup, maintenance, and provisioning tasks require insight into the physical network. Number two, logical. The logical network of topology is a higher level idea of how the network is set up, including which nodes connect to each other in which ways, as well as how data is transmitted through the network. Logical network topology includes any virtual and cloud resources. Effective network management and monitoring require a strong grasp of both the physical and logical topology of a network to ensure your network is efficient and healthy. So let's go to circuit switching. What is circuit switching? Circuit switching is a method of implementing a telecommunications network in which two network nodes establish a dedicated communications channel through the network before the nodes may communicate. So, what is circuit switching? The example of circuit switching is an analog telephone network. It contrasts with packet switch networks, which break the communication into packets and then send those packets through the network independently of one another. So, is circuit switching still used? The old telephone system, or PSTN, uses circuit switching to transmit voice data, whereas VoIP uses packet switching. And however, there are still advantages to using the latter. We compared packet switching and circuit switching to help you understand what each one does. So, do cell phones use circuit switching? No. I'm sorry. The short answer is both. Traditionally, when a voice call is placed, it goes over a circuit switch network. However, in the last few years, VoLTE, or Voice over LTE, has been rolling out and enabling voice calls to take place over a packet switch network. So let's proceed to message switching. Message switching is a network switching technique in which data is routed in its entirety from the source node to the destination node, one hop at a time. So during the message routing, every intermediate switch in the network stores the whole message. Okay, so what is the example of the message switching? Sorry. The example of this is thus a example of a delay system or a queuing system. Message switching is still used for telegraph traffic and a modified form of it, known as packet switching. And it is used extensively for data communications. So, what are its drawbacks of message switching? So the primary disadvantage of message switching is that it cannot be used for real-time applications like voice or video calls, as the message can be any length, so each node must have a sufficient buffer to store the message. So yeah, that is the message switching. So the next one is called the packet switching.
So what is packet switching? Packet switching is the transfer of small pieces of data across various networks. These data chunks or packets allow for faster, more efficient data transfer. Often, when a user sends a file across a network, it gets transferred in smaller data packets, not in one piece. For example, a 3 MB file will be divided into packets, each with a packet header that includes the origin IP address, the destination IP address, the number of packets in the entire data file, and the sequence number. Types of packet switching. There are two major types of packet switching. Connectionless packet switching. This classic type of packet switching includes multiple packets, each individually routed. This means each packet contains complete routing information, but it also means different paths of transmission and out-of-order delivery are possible, depending on the fluctuating loads on the network's nodes, adapters, switches, and routers at the moment. This kind of packet switching is sometimes called datagram switching. Each packet in connectionless packet switching includes the following information in its header section: source address, destination address, total number of packets, sequence number for reassembly once the packet reached their destination via various routes, the receiving device, rearrange them to form the original message. Connection-oriented packet switching. In connection-oriented packet switching, also called virtual circuit switching or circuit switching, data packets are first assembled and then numbered. Then they travel across a predefined route sequentially. Address information is not needed in circuit switching because all packets are sent in sequence. So the next topic is implementation of packet switching. Number one, data split into chunks, packets. Number two, each packet has a form from address to address and payload, data chunk. Number three, if data requires multiple chunks, then the order of each packet is noted. Number four, packets sent onto the network, moving from router to router, taking different paths set by the router. Each packet's journey time can therefore differ. Number five, once packet arrive, they are reordered. Number six, message sent from recipient to sender indicating that the message has been received. And last, number seven, if no confirmation message, sender transmit data again. That's the end of the implementation of packet switching.
Relationship between packet size and transmission time. Packet size affect performance of network a lot. First and foremost, every medium of transmission specifies MTU, i.e. maximum transmission unit. If packet is no more than MTU, it will be dropped. Now, question is how. There is something called bandwidth. Example, maximum number of bits per second in order to guarantee reasonable level of reliability. Packet is single unit and considered to be transferred over small time. A larger packet will take long time to transfer, resulting into more collisions at layer 1. The medium of the transmission, i.e. copper wire or twisted pair, transfer electrons based on their mobility. This restriction affects the rate of data transfer over them. A large packet would mean others won't get a chance to use the transmission line. Apart from this restriction, buffers on in IC and OS have memory size restriction. A large packet size would mean large memory allocation and intermediate boxes as well as end hosts. If your packet size is large, in high probability it will get drop at Q, whose element size is small or in worst case get fragmented, which is more computationally intensive than retransmitting in form of small packets. That is all.
That is all for today. Thank you. Okay, good day, and right now we are reporting for the comparison of switching techniques, multiplexing, FDM or frequency division multiplexing. WDM stands for wavelength division multiplexing. TDM stands for time division multiplexing. Okay, so introduction of this report is the most fundamental need of any communication system design is to cater to large number of users, but this requires a large number of resources and large bandwidths supporting multiple channels. Requirement for large number of resources can be met if the resources are available, but this makes it cost ineffective. Therefore, The aim is always to use minimum number of resources and make their utilization to their fullest potential. Bandwidth always remains a critical resource due to its limited availability, and therefore communication systems try to harness its fullest potential. Networks always require us to accommodate multiple signals utilizing a single piece of cabling to make it cost effective and reduce complexity. This need is seen throughout networking, whether we are talking about local area networks or wide area ones. Modern telephone systems must place a large number of calls over a limited amount of bandwidth. Example, a trunk. Broadband LANs or LANs must have several different types of data on a single wire at once. For these applications, we need to share the resources and in particular the bandwidth. Multiplexing and switching are the two most important techniques being employed for this purpose in the present-day communication systems and have been discussed in a present unit. Okay, so one of the reports in this concepts of communication and networking is multiplexing concept. In general, a medium can carry only one signal at any moment in time. For multiple signals to share one medium, the medium must somehow be divided, giving each a signal portion of the total bandwidth. Multiplexing, also known as muxing, is a method by which multiple analog message signals or digital data streams are combined into one signal over a shared medium. The basic aim of the multiplexing is to share an expensive resource by putting up multiple signals on the same channel. For example, in telecommunications, several telephone calls may be carried using one wire. Multiplexing originated in telegraphy in the 1870s and is now widely applied in different streams of communications. When several communication channels are needed between the same 2 points, significant economics are may be realized by sending all the messages on one transmission facility called multiplexing. Multiplexing refers to the ability to transmit data coming from several pairs of equipment. It is called low-speed channels on a single physical medium, whereas a multiplexer is the multiplexing device that combines the signals from the different transmitters and sends them over the high-speed channel. A demultiplexer is the device which separates signal received from a high-speed channel into different signal and sends them to receivers. So there are 4 basic multiplexing techniques. 1 is frequency division multiplexing. 2 is time division multiplexing. 3 is code division multiplexing. 4 is space division multiplexing. And the other one are the frequency division multiplexing. Cut na naman! Cut. 6 minutes. Okay, 6 minutes in, out. Alright. Okay, so frequency division multiplexing. Frequency division multiplexing is the technique used to divide the available bandwidth into a number of smaller independent logical channels, with each channel having a small bandwidth. The method of using a number of carrier frequencies, each of which is modulated by an independent speech signal, is in fact frequency division multiplexing. It depicts the basic process of frequency division multiplexing, in which the total bandwidth has been divided into n number of different channels, and each one of them working with a specific bandwidth. Frequency division multiplexing. Frequency division multiplexing. In the telecommunication technology, the total bandwidth available in a communication medium is divided into a series of non-overlapping frequencies, subbands using the frequency, and division multiplexing. Each one of these subbands then carries a separate signal. This allows a single transmission medium, such as a cable or optical fiber, to be shared by many signals. An example of a system using FDM is cable television, in which many television channels are carried simultaneously on a single cable. FDM is also used by telephone systems to transmit multiple telephone calls through high-capacity trunk lines, communication satellites to transmit multiple channels of data on uplink and downlink radio beams, and also broadband DSL modems to transmit large amounts of computer data to twisted pairs of telephone lines. Among many other uses, frequency division multiplexing works best with low-speed devices. The frequency division multiplexing schemes used around the world are very standardized. A widespread standard is 12 to 4000 Hz each. Voice channels are like 3000 Hz for user plus 2 guard bands of 500 Hz each. Multiplex into the 60 to 108 kHz band. So many carriers offer a 48 to 56 kilobytes per second leased line service to customers based on the group. In telephony, the most widely used method of modulation in FDM is single sideband modulation, which in the case of voice signals requires a bandwidth that is approximately equal to that of the original voice signal. Each voice input is usually assigned a bandwidth of 4 kHz. The bandpass filters following the modulators are used to restrict the band of each modulated signal to its prescribed range. The resulting bandpass filter outputs are combined in parallel to form the input to the common channel. At the receiving terminal, a bank of bandpass filters with their inputs connected in parallel is used to separate the message signals on a frequency occupancy basis. The original message signals are recovered by individual demodulators. So advantage of FDM is the users can be added to the system by simply adding another pair of transmitter modulator and receiver demodulators. Second is the FDM system support full duplex duplication. So both sides simultaneous communication flow, which is required by most of application. Disadvantages of FDM. Number 1. In FDM system, the initial cost is very high. This may include the cable between the two ends and the associated connectors for the cable. Second is a problem with one user can sometimes affect the others. Third, each user requires a precise carrier frequency for transmission of the signals. Alright.
Time division multiplexing. Time division multiplexing, or TDM, is another popular method of utilizing the capacity of a physical channel effectively. Each user of the channel is allotted a small time interval during which it may transmit a message. Thus, the total time available in the channel is divided and each user is allocated a time slot. Data from each user is multiplexed into a frame which is transmitted over the channel. In TDM, users' messages are buffered as they receive and read from the buffer during its time slot to make a frame. Therefore, each user can use the full channel bandwidth. The channel capacity is fully utilized in TDM by interleaving a number of messages belonging to different users into one long message. This message sent through the physical channel must be separated at the receiving end. Individual chunks of messages sent by each user should be reassembled into a full message. Applications of TDM. The PDH, or Presynchronous Digital Hierarchy System, also known as the PCM, or Pulse Code Modulation Systems. The Synchronous Digital Hierarchy, or SDH. Synchronous Optical Networking, SONET Network Transmission Standards. TDM can be further extended into the time division multiple channel TDMA scheme, where several stations connected to the same physical medium, for example, sharing the same frequency channel, can communicate. Application examples include the widely used GSM telephone system. Advantages of TDM. Number one, it uses a single link. Second, it does not require precise carrier matching at both ends of the links. 3. Use of the channel capacity is high. 4. H to expand the number of users on a system at low cost. 5. There is no need to include identification of the traffic stream on each packet. Disadvantages of TDM. 1. The sensitivity to other user is very high and causes problems. 2. Initial cost is high. 3. Technical complexity is more. Code division multiplexing. As you may know, the concept of multiple access where we can allow several transmitters to send informa- information simultaneously over a single communication channel, and it allows several users to share a band of frequencies, or you can say bandwidth. CDMA uses spread spectrum technology and a special coding scheme where each transmitter is assigned a code, generally pseudo-random code, to allow multiple users to be multiplexed over the same physical channel. By contrast, time division multiple access TDMA di- divides access by time, while frequency division multiple access FDMA divides it by frequency. CDMA is a form of spread spectrum signaling since the modulated coded signal has a much higher data bandwidth than the data being communicated. This allows more users to communicate on the same network at one time than if each user was allotted a specific frequency range. Remember that CDMA is a digital technology, so analog signals must be digitized before being transmitted on the network. Phase division multiplexing. When we want to transmit multiple messages through any of the communication media, The ultimate goal is to maximize the use of the given resources. For example, time and frequency in general. It involves grouping many separate wires into a common cable enclosure. A cable that has, for example, 50 twisted pairs inside it can support 50 channels. SDM has the unique advantage of not requiring any multiplexing equipment. It is usually combined with other multiplexing techniques to better utilize the individual physical channels. For example, if there are 6 persons in the office and all of them want to talk at the same time, this will give rise to interference between the conversations. To reduce the interference, they may divide themselves between into 3 groups of 2, such that the conversation is between each pair of people. If the pairs continue talking while sitting to each other, the interference would still be present. The best way for each pair to converse with minimal interference would be to sit a few feet away from the other pairs within the same room and converse. They would still be sharing the same medium for their conversations, but the physical space in the room would be divided for each conversation. This is the simplest example of space division multiplexing. Summary. We hope you must have understood the concept of multiplexing and switching. As we discussed, multiplexing refers to the ability to transmit data coming from several pairs of equipment, transmitters and receivers called low-speed channels on a single physical medium called the high-speed channel, whereas a multiplexer is the multiplexing device that combines the signals from the different transmitters and sends them over to the high-speed channel. Further, in this unit, you have studied 4 basic multiplexing techniques: are frequency division multiplexing or FDM, time division multiplexing or TDM, code division multiplexing or CDM, and space division multiplexing SDM. As you have studied that switching plays a very important role in telecommunication networks. It enables any two users to communicate with each other. Basically, there are 3 categories of switching like message switching, circuit switching, and packet switching.